How's it going? My name's Tanner Sullivan. I'm here to talk about the topic of training to improve anaerobic power and muscular strength. I'm doing this for exercise physiology for Brother Kimple, and I hope you enjoy. So before we get start talking about any modes of training or anything of that nature, we're going to need to talk about the types of anaerobic energy systems we're going to be using during the exercises that we're going to be performing. So during anaerobic exercise, the two main energy systems we're mainly going to be focusing on are the ATP-PC system and the glycolytic system. These systems provide fast and rapid ATP to high-intensity exercises that are over a shorter duration, around either between 0 to 10 seconds or 10 to 90 seconds. Muscular strength refers to how much force a muscle or a group of muscles can produce during a lift or a sprint or something like that. Neural adaptations can also be a high factor of how much muscular strength you can perform. We'll get into that a little bit more in a second, but we're going to talk about motor units and neural recruitment during that. So cardiac output is another very important factor of anaerobic training. You can measure your cardiac output by multiplying your heart rate times your stroke volume. The next thing we're going to be talking about is neural recruitment, like I said before, and how it influences your force output. So it's really dependent on your training time period, how long you've been training, how long you've been like running or lifting, for example, and how much force you can generate for that activity. Some general principles of anaerobic training include we need to be very specific about which energy system we're training, whether it be the ATP-PC system or the glycolytic system. Overload and progression are another important factor because we need to understand that as we train, as we are exercising over a long period of time through a couple weeks to a couple months, our bodies are going to adapt and become stronger. We're going to have more anaerobic power. We're going to have more muscular strength. And with that, we're going to need to increase the intensity or the volume of a workout. And so we're going to need to look at that. Work to rest ratio is a very important thing. It really matters because dependent on what energy system we're trying to hit, we're gonna do a different rest period amount of time. So let's say if we're wanting to do more of the glycolytic system, we're gonna have a high intensity exercise in between 30 and 90 seconds, but we're gonna only have the rest time between 30 and 90 seconds. So the exercise time is between 10 and 90 seconds, and we're gonna have a rest time of 30 to 90. Intensity determines adaptation, and so higher intensity exercises are going to put more strain and stress on your muscle, and so that's why these higher rest time intervals are required for hitting these systems. Neural and metabolic adaptations are very important because the more neural activity we can have to an area, let's say to your quadricep in kicking a ball or performing a squat, the more you repeat that action, the more you train that action, the more neural recruitment you're going to be able to put into that muscle, and the more strength you're going to be able to get out of it. So now let's dive into the ATP-PC system. So this system has an intensity exercise range around 0 to 10 seconds. So it's going to be a very short period. This could be a sprint if you're really crazy sprinting. This could be a resistance lift that, let's say you're doing a 1 rep max, or you're doing strength training with like a set range of 3. It's going to take you probably less than 10 seconds to do that. So you're going to be recruiting the ATP PC system. The ATP PC system is used in maximal efforts, and so it's going to be very high intensity. You need a longer recovery time of around 2 to 5 minutes, and so you can let the phosphocreatine stores recover and replenish before your next effort or next sprint or next lift set. These are some examples like sprints, jumps, heavy lifts. This could either, glycotic system training. The duration is around 10 to 90 seconds, and this could be either a longer sprint, like you could do like a 400 or something, or this could include sports like football, hockey, where you have those high intensity, a little bit of longer duration, but not too long, around 10 to 90 seconds. So high intensity intervals of, once again, 10 to 90 seconds are very important to recruit the glycotic system. The rest time that is given for the glycotic system and enabled for you to hit the glycotic system is around 30 to 90 seconds. And so you're producing more lactate. You're going to uptake your you're going to improve your lactate. You're going to improve your lactate tolerance, and in doing that, you're going to increase your anaerobic power and your anaerobic endurance. So, it increases your lactate tolerance and enhances anaerobic endurance by doing that. Training to improve muscular strength. So, PRE, progressive resistance exercises. This once again goes back to how you need to add more and more weight as time goes on, because your body's going to be adapting to becoming stronger. And if you keep your training at a certain weight and a certain volume, you're not going to improve past a point, because your body's going to get used to it and it's going to adapt to it, heal to it. So to do a little bit more strength training, you're going to want to be within the 1 to 6 rep range, because that's going to just improve your overall strength. Neural adaptations are very important, once again, because as time goes on, beginners, especially in resistance training, will notice a very large increase in their strength, and that's mostly because of their ability to recruit more motor units and more neural activity to the area. Hypertrophy follows overload, because as you strength train, your muscle fibers are going to get bigger, so it's pretty cool. Recovery is very essential, and so these, depending on the rest times you want to do, you need to have a little bit of a longer rest time to allow those phosphocreatine stores to replenish. So let's get on to free weights versus machines. They both provide very interesting benefits to them. Like, let's take free weights for example. Free weights help they'll recruit more of your stabilizers over time, because let's say you're doing a bench press, right? And so there's nothing keeping your arms from going this way, right? And so you need to recruit those stabilizers to keep the bar going in one plane of motion and not rotating all over the place. And so that's one of the very good benefits that free weights has, is it recruits the stabilizer muscles and helps with that. Machines, you can do a very controlled movement. You can target specific muscles by altering the pull of gravity, because you can have the cable coming from the side, and instead of just having the resistance coming from down up, you can have it coming from the side. You can have it coming at an angle. So it's really, really usable for different planes of motion. Similar strength gains are possible. Some research has been done, and It just really depends on what you're wanting to exercise and what your goals are to use either free weights or machines. Injury risk depends on supervision, so it honestly depends on how experienced the lifter is, how, let's say there's like some supervision and someone helping you with your form or spotting you during an exercise, then you can confidently do free weights. But with machines, you can be very inexperienced and still be relatively safe with injury. And so you're not having like a bar fall on your face or something. So current research with anaerobic power. So sprint interval training improves overall power, which is really cool. Phosphocreatine recovery adapts with training, and so as you train your ATP PC system, as you do more and more lifts, that recovery time of 2 to 5 minutes can shorten closer to 2 minutes. As you get more and more trained, your phosphocreatine stores will be able to recover faster, and you can use a little bit shorter rest periods. High intensity interval training enhances glycolytic enzyme activity and helps your body and your these enzymes to provide ATP and energy really fast during those high intensity, small duration exercises. Neural drive increases early strength gains, like I was saying. Early on in a lifter's career, or if they're just working out, they're going to notice these strength gains pretty early on, and they're going to be pretty shocked by it because it's mostly just your neural efficiency to an area of the muscle. So the current research for strength training, similar gains can be found between men and women, given they're doing the same workout and repeating the same exercises. Velocity-based training enhances power, and so we can control the speed on how fast we do an exercise. Like, let's say we're doing a weighted box jump, and instead of doing it slow, you can do it faster, and it has more of an effect on your workout. It enhances it a little bit more. So combining strength training and sprints improves overall performance. This is because you can get more neural activation to the area. Once again, neural activation is a very important point in anaerobic and muscular strength training. Periodization improves long-term outcomes, and so these are some of my references, this is from our notebook. So some practical application can vary from athletes to physical trainers to physical therapists. Some athletes might include some football players that are on the field for not very long, and they're using those high intensity energy systems to get their job done. Or like hockey players where they're out for less than 90 seconds or a minute and a half, and then they're on the bench for a little more than 2 minutes. They're going to be hitting that ATP PC system. And so it's very important to train these systems for athletes like this. Some practitioners like strength coaches, athlete coaches, physical therapists might use these training methods to help recovery in a patient or help improve a athlete that they have, which is really interesting and really cool to see. Once again, it's used in rehab and performance programs through physical therapists and coaches. It enhances speed and injury prevention, and so anaerobic power and muscle strength will help increase your sprint time or how much you can lift and stuff. So it's really cool. So summary: the ATP PC system is very explosive. It's very short term, less than 10 seconds. You need a longer recovery time, around 2 to 5 minutes. But the glycolytic system is a little bit longer of a duration, but it's still a very short duration of around 10 to 90 seconds. And it's very high intensity, just like the ATP PC system. Progressive overload is essential because as you are weightlifting more, as you're sprinting faster and faster, you're going to want to put more load on your muscles than you were before, because that's the only way you can increase your anaerobic power and muscular strength is by overloading every time and increasing the intensity. Application spans sport and health. So like I was saying, like sport coaches, trainers, like strength coaches, physical therapists, occupational therapists, whatever, will and can use this to help their athletes or patients. So this is my the interactive quiz that I have for you guys. I'll give you around a minute to answer that and be good. I'll give you the answer in a second. So let's go through the answers. So what is the primary fuel source for the ATP PC system? Primary fuel source for the ATP PC system is phosphocreatine, as I was explaining. Those phosphocreatine stores need to replenish during that long duration rest period, around 2 to 5 minutes. How long does the ATP system dominate? The ATP PC system dominates around 0 to 10 seconds of your training interval. And so you also need to have maximum effort and max intensity to hit the ATP PC system. What is a cardiac output? Heart rate times stroke volume, right? This is the amount of blood your heart can pump per minute. What rep range is best develops maximal strength? It's around 1 to 6 reps per set. These are seen to have the best impact on muscular strength gains. What rest interval best trains the ATP PC system? And it's around 2 to 5 minutes. And once again, the 2 to 5 minutes is there to allow the phosphocreatine stores to replenish. True or false? Women gain strength at similar relative rates as men. It's true. Which energy system predominates in a 400-meter sprint? That would be the glycolytic system, because it wouldn't be the ATP PC system, because it's around 0 to 10 seconds, and that'd be pretty impressive if you can do a 400-meter sprint in that amount of time. So the only other one is glycolytic system, and it is around 30 to 90 seconds, and a 400-meter sprint is definitely doable within that time. And so thank you very much. This has been my presentation on improving anaerobic power and muscular strength. Have a great day. Thank you.